The topic for this video will be the ambiguous case of the sine law. In the last lesson we looked at the sine law itself, and you may have noticed that we were never given two sides and a non-included angle in that previous lesson. That's because this is known as the ambiguous case because there are three possibilities of how it can work out. So we're going to go through those three possibilities. Let's first discuss what we mean by two sides and a non-included angle. So let's say I was given this side AB, and I was given the angle, this angle right here that's labeled as given, and then a third side, so let's say this side here in red. So I would have this side right here would be given, this side right here is given, and the angle that's given is not between them. So included angle means that it would be between them. That would be the included angle, but that's not what is given in this case. We're given an angle that's not between the two given sides, and that introduces this possibility of the ambiguous case. So first, consider being given a line segment, and an angle at one end of that segment is shown here. So we've got basically a triangle going here, and this third side is the one that's going to be the problem here. So let's scroll down and look at the first possibility of the ambiguous case. So consider a third side that is opposite the angle. So now we have two sides and a non-included angle, and it's barely long enough to reach the other side. So right across here like this, it's just barely long enough. So we're given this side, again we're given this side, and we have this given angle is not between them, so it's a non-included angle. And that, if it's just long enough, it ends up being a right triangle, and it makes a perpendicular there. And mathematically we'll know that we have this when the sine calculation of an angle yields a value of 1, and we need to remember that sine of 90 degrees is equal to 1. So in other words, we have a 90-degree angle in that triangle. That will alert us that we have a side that's just barely long enough to reach. Now let's look at case number 2. Consider a third side that is opposite the angle and is too short. So for example like this, it doesn't matter if I put it back this way or lean it this way, it won't reach. And that's the second case that's possible with an ambiguous case. And you'll be alerted to that when we have a sine or cosine value that is outside the acceptable range. Cosine or sine of any angle in degrees should always be between -1 and 1. If it's outside of there, then that tells us we've got a problem. The side won't reach. There's no way to make it work. So that's case 2. Case 3, this one, we have a side that's long enough to reach, but it will reach in two places. So here's what I mean. If I have a side length that, let's say it's this long right here, it could reach there, or that same length, it's reaching to here in that first case. Well, it actually will also, if I rotate it more, it'll reach back that direction too. So anyway, there are two possibilities for the angle. And we'll discuss that. Two different triangles are possible, and it must be decided from the physical situation which one is best. So can you accept both of them, or should one of them be rejected because it doesn't make any sense for the problem situation? So those are the three possibilities when you're working with the law of sines and you have two sides that are given and an angle that's not between the two. Example 1 here will be representing that first case where the side will just happen to be just long enough to reach the other side. So if we sketch this out, we'll draw it like this and label it triangle A, B, and C like this, and this will be the side that is the side that just barely reaches. So side B is equal to 20, so that's this side. Side C is equal to 10. And angle C is equal to 30. So how do we know we have the ambiguous case? Because we're given two sides, these two sides, and an angle that's not between them. So that's where we have the possibility for a problem. So we're working to find the rest of the triangle here, and we'll use law of sines to do that. We have a complete sine ratio here. We have angle C and side C, so we can use that sine of 30 degrees over side length C there, so we're using this angle on this side, is equal to, well, right now I have side B is 20, so I'm going to be finding angle B here, so that would be sine of angle B. So we cross multiply and we get 20 sine 30, that's this cross multiply, equals 10 times sine B, equals 10 times sine B. Solve for sine B there, divide by 10, and come up here, we get sine of B is equal to 20 sine of 30 degrees, all divided by 10. And notice we're finding an angle measure here, so we'll need to do the inverse sine. So finally we get let's do it this way, B is equal to, angle B is equal to sine inverse of this whole chunk here, so 20 sine of 30, all divided by 10. And let's put that in our calculator here. And we're already in degree mode, so second sine inverse alpha y equals enter. I'm going to put this in as a fraction. It's much easier. 20 sine 30 over 10. And we get 90 degrees. So angle B here is 90 degrees. So that's the case where this side is just barely long enough to reach. So that means that this angle would be 60. We have a 30, 60, 90 triangle. And we want to find side A next. So we'll stick with the ratio that we began with. Sine of 30 over 10 is equal to, we're finding angle A here, side A, so we'll use angle A here, sine of 60, this angle, over side A. So cross multiply, we get A sine of 30 degrees equals 10 times sine of 60 degrees. So A is equal to, change colors here so we can see what's going on, 10 times sine of 60 degrees all over sine of 30 degrees. Bring our calculator up here and put that part in green in our calculator. So clear that out. Let's put it in a fraction form. It's much easier to see. 10 sine 60 over sine 30. And we get 17.32 for this side. So we have the triangle solved, and this was case one where this triangle happened to be a 90-degree triangle, where this side right here was just long enough to reach from this point to this point. Okay, example 2 here, solve this triangle. So we'll draw same rough triangle we've been using we used in the previous one. So make this A, this B, and this C, and then label what we're given. So we have side B is 20, side C is 7, and angle C is 30 degrees. So we have the situation where we're given two side lengths and an angle that's not included. In other words, it's not the angle between these two sides. So this is where we have the ambiguous case, and it's going to be either just long enough to reach in two places, or not long enough to reach at all. And in this case, it's not going to be long enough to reach at all. That was our example, our case 2 that we looked at before. But we don't know that yet, so let's go through the work. So we need a complete sine pair to use the law of sines. So I have this pair right here. I have the angle on the side that goes with it. So I'll just write it out first. Sine of C over C is equal to sine of, in this case we'll use B, sine of angle B over side B. That would be our first step to find angle B here. So I should have used this because we're not actually filling it in yet. So this is our setup. We know all of this and we know that part of this one, so we're just left with one missing piece, so we can use law of sines here. So sine of C would be sine 30 degrees over side length C is 7, and that's equal to sine of our unknown angle, angle B, over side length 20. So sine of angle B is equal to 20 sine 30, 20 sine 30 all over 7. If we do our work there. I'm shortcutting this a little bit. So if we do this from this point, we would have sine inverse sine of angle B is equal to this whole chunk. So 20 sine 30 all over 7. And we're going to have a problem when we do this. Second sine inverse of alpha y equals enter. I'm going to make this a fraction so it's easier to see. 20 sine 30 all over 7. And we get an error. Okay? So let's check what is this part right here. What is that equal to on its own? So alpha y equals enter. And that would be 20 sine 30 all over 7. And that's equal to 10/7. We want a decimal there. That's bigger than 1 is the point here. It's 1.42. So basically we are saying that sine of angle B is equal to 1.43 rounded. Well, we discussed before, sine of any angle, whatever the angle is, has to produce a value between 1 and -1. If it's outside of that range, that means it can't happen. So that means that angle B, we're not going to be able to find it, because that's saying that this length of 7 is not long enough to reach over here to this side. So we actually have this situation. With a side of 20 in length and a 30-degree angle here, the side that's anchored right here to point A has to be big enough to reach. Well, 7 is not big enough. In other words, this angle being 30 degrees with a side length of 20, as it goes off back in this direction, the side length of 7 would not be long enough to reach. It doesn't matter how we rotate it. We take our side length of 7, we rotate it this way. There's no way that it's going to ever reach this side with that scenario. 7 is too short. So we say that this triangle is not possible. Triangle not possible. And we stop there. So this triangle, there's no way that that triangle could exist. Side C over here is too short to reach.